What if the James Webb Space Telescope has looked to the very edge of the observable universe and discovered something that should not exist? For decades, scientists believed they had a reliable picture of how the first galaxies, stars, and black holes formed after the Big Bang. According to that model, the early universe was supposed to be young, chaotic, and unfinished, a cosmic construction site where gravity had only just begun pulling matter together into the first structures. But Webb is revealing a very different story. At the edge of observable time, the telescope has detected enormous stars, surprisingly mature galaxies, and black holes so massive that they appear to have grown before the universe had enough time to create them. As Webb continues to observe the distant cosmos, the pattern becomes increasingly difficult to dismiss. These are not isolated anomalies. They are clues suggesting that the early universe may have been far more organized, far more violent, and far more mysterious than existing theories predicted. If these extraordinary objects truly formed only a few 100 million years after the Big Bang, then the most important question is no longer what Webb found, but what kind of universe could have produced them so quickly. Before Webb transformed our understanding of the distant universe, it had already begun reshaping what scientists believed about nearby planetary systems and the potential for life beyond Earth. In the TRAPPIST-1 system, located roughly 40 light-years away, Webb studied a family of 7 Earth-sized planets orbiting a small red dwarf star. The system quickly became one of the most important targets for astronomers searching for habitable worlds. The closest planet, TRAPPIST-1b, appears to be an extremely hostile world. Webb's observations indicate surface temperatures around 230 degrees Celsius, making it more like a scorched version of Mercury than a planet capable of supporting life. Current measurements also suggest that it lacks a substantial atmosphere, leaving little protection from the intense radiation of its nearby star. When Webb turned its attention to TRAPPIST-1c, however, the story became far more complicated. Scientists had long suspected that this planet might resemble Venus, with a dense atmosphere trapping enormous amounts of heat. Instead, Webb's observations suggest that the comparison may not be so simple. The planet's day side appears to reach temperatures of about 100 degrees Celsius, while regions closer to the night side or the boundary between day and night could become dramatically cooler, possibly even dropping below freezing. Yet the data also indicates that TRAPPIST-1c may lack a thick atmosphere altogether, leaving astronomers with a world that is not quite like Venus, not quite like Mercury, and unlike anything familiar in our own solar system. Webb then turned toward the Orion Nebula, one of the most active stellar nurseries in our galaxy, and made another significant discovery. It detected carbon-based compounds within regions where young stars and planetary systems are actively forming. This finding matters because carbon chemistry forms the foundation of life as we know it. Long before Webb began challenging cosmology, it had already demonstrated that planets, atmospheres, and the essential ingredients for life are more widespread, more complex, and more surprising than scientists had imagined. But the telescope's greatest surprise lay much farther away. When Webb looked toward the edge of the observable universe, it uncovered a discovery that immediately created a serious timing problem for cosmologists. Only about 440 million years after the Big Bang, it detected evidence associated with some of the largest stars ever observed. These stellar giants appear so extreme that their existence seems almost impossible in such a young universe. Some of these stars are believed to have been thousands of times larger or more massive than our Sun, true cosmic monsters forming at a time when the universe should still have been assembling its very first major structures. This is what makes the discovery so remarkable. Stars require enormous clouds of gas, and those clouds need time to gather under gravity before collapsing and igniting nuclear fusion. According to the standard model of cosmology, the first stars certainly could form in the young universe, but the appearance of enormous stellar objects so soon after the Big Bang places tremendous pressure on that timeline. It is like discovering a fully grown forest in a place where only the first seeds should have begun to sprout. When stars form this early and this violently, they do far more than simply shine. They flood surrounding space with intense radiation, forge heavier chemical elements inside their cores, explode as supernovae, and create the raw materials from which future galaxies, planets, and perhaps even life itself will eventually emerge. If Webb's observations are correct, then the first stars may not have been modest beginnings. They may have been colossal engines that dramatically accelerated the evolution of the universe. That possibility could explain why the early universe appears far more developed than existing theories predict. Then Webb discovered something that made the mystery even more difficult to ignore. In a distant galaxy known as GNZ11, astronomers detected evidence of a colossal black hole dating back to a time when the universe was only about 570 million years old. This black hole appears to possess a mass equivalent to roughly 9 million suns. In cosmic terms, that means it became enormous almost immediately after the universe began. According to current theories, this should be extremely difficult to achieve. Black holes grow by consuming gas, stars, and surrounding matter, but there are physical limits to how quickly they can feed. Radiation generated by the infalling material pushes outward, slowing further growth. Gas must gradually spiral inward, and the host galaxy must continually supply fresh material. Every stage of the process requires time. Time, however, is exactly what the young universe did not seem to have enough of. As a result, this black hole represents much more than a distant astronomical object.